unlike that very excellent data-rich analysis and conclusion-rich manuscript, talk, excuse me, this is going to have no data whatsoever. This is basically a summary of a manuscript that Alex Gatch and Robert de Bruni and I independently all thought needed to be done, and then got together and we're doing it together, which is that we've spent a lot of time inventing and using and failing with gear to sample early life stages, and more people need to sample early life stages, and I'll describe a little bit why. And so let's just put a summary together. What works, what doesn't work, why does it work, which sampling gear do you need for what question, which ones are quantitative, which ones are not quantitative, and so forth. Do you really have to have divers? And that is great, but you know, it's a specialized skill, etc. So for this, this, it would for,
just quick screen, just get it into the system.
There you go.
Try it now.
Right. Yeah.
All right.
For this talk, I'll talk specifically about salmons, i.e. lake trout. And the techniques that we use for lake trout that have been going on for longer are relatively transferable to crigonines. And so Robin's actually going to be leading a paper that focuses particularly on crigonines, and we sort of go back and forth between the two. These are both lithophilic, and I've got to stop saying lithophilic spawning species, i.e. they spawn on the bottom, dropping their eggs on rocky substrates of one form or another, gravel to cobble. And so, of course, we can include things like sturgeon in this group. If you want to find sturgeon eggs, the techniques are much the same, though the larval techniques would be a little different in rivers than in a lake spawning. So we're looking at lithophilic, lacustrine spawning species. So, why? I mean, let's just ask why we want to sample early life stages. I mean, we study adults, we manage adults, we want to know about stock size, we do assessments on adults, or at least large juveniles in adults. The point is that we're fisheries biologists or fisheries researchers. It's what we do, right? And more to the point, it's what we know how to do. I mean, everybody grows up doing the hauling nets and the dragging nets and doing the electroshocking on large fish. And I'm talking about very, very small fish in very early life stages. So, what if your year classes fail? Well, you might not have adult fish to sample, and what you want to know is why did they fail? Either they died as adults because there's too much fishing or predation or not enough food or something like that, or there aren't enough of the little ones. There's something happening very early in the life stage. This is sort of obvious, but worth going over. What if you've got population restoration and it's not working, or you're trying to? This has been a lake trout problem for well over 6 decades. Which is, you just put them in there and they don't reproduce. Why? Is it the substrate? Is it the life stage? Are they spawning but not hatching, and so forth? Or you've just built yourself an artificial reef and you want to know whether it works. Mark, excuse me. And Sam, right? That's an artificial reef. Are they doing anything with it? Is it working? So it's sort of obvious why we need it. Reality checks. We're studying lake trout. They spawn at an awful time of year to be working, right? It's cold and it's the worst, jet stream generated stuff, and often it's deep. I mean, these fish spawn to well below 50 meters in places, and that has its own set of challenges working with it. And then they hatch at an awful time of year when the ice is still out and you're in and you can't get out there. And this is one of my graduate students. Please don't do that. Walking across the ice to launch the dinghy. Wow. It took years off my life, he did. And then, so the thing is, we fail a lot. You read the papers, you go, wow, that was really cool, that was really effective. We don't tell you about all the awful things that happen, the amount of gear that ends up being trashed or never recovered, or it's displaced to the bottom of the reef. On this slide, you can just see that that's a trashed fry trap there. The divers are just booking past it, but there were just all these trashed fry traps because the weather's really rough and it does a lot of damage to this gear. So, first lesson, right? Never underestimate what the weather's going to do to your gear. The deeper you are, the safer you are, but then, as I said, that's got its series of challenges. The other thing is that, and this is the big difference with early life stages from later, none of this stuff is off the shelf. You can buy a gill net. Right? We're inventing this stuff as we go along. And that means there's a lot of fabrication skills, there's a lot of how do we do this. You've got to have a crew that's got skills. And the Dunkirk lab in particular, I'm looking at Jason over here, has got that in spades. And some just amazing fabricators with great ideas about how to do stuff. So let's just look at what's happened. You know, this was one of the earliest papers. This was Tom Stauffer, who looked at, he did red trawls, and he did fry traps, and he did all sorts of great stuff. And that was back in about 71, I think it was. And then papers come in different techniques. You know, we've just been doing this, as I say, for a while. I'm sorry Brian Wydell isn't here. He invented a lot of nuclear recently and keeps doing that. But folks from his shop and his colleagues are here. So, let's look at them. General categories, egg sampling. That's the first thing. This life stage that is most abundant and least likely to swim away. Therefore, it's a really good stage to be sampling. And this is probably the hardest stage, honestly, because of that rough weather. But we've got egg nets and we've got egg traps. They give you, the advantage of those is they're surface deployed, but they only give you relative egg density, eggs per trap per day, depending on how many traps you put out there, or nets, or whatever. If you want to go quantitative, suddenly you've got to have divers. Because the way to do these, basically, is to put something into the substrate that's locked into the substrate, which you can only do from being there. And then you can get absolute densities of how many eggs per unit area that you've got. Another way of doing it, and again, this is diver deployed, but it's surface operated, is you bury an egg funnel into the substrate, fill it with substrate, and so the lake trout come in, as they do with the egg bags, they spawn in the area, eggs trickle down, and you've got eggs per unit funnel, but from the surface, you're basically standing there with a tube that goes out to the surface, and you're doing a bilge pump and pumping them, which means you can get a time series. You can pump them every day. How many did they spawn in there last night, last week, whatever? And that's a huge advantage if you want to know what the time sequence is spawning is. Then fry, okay, these are free embryos, but we said in the paper, if anybody read it, that fry is the useful term. This is the newly hatched to leaving the reef stages, about a 6-week period. Been lots of ways. This is probably the earliest one. This is a Stauffer design, the big square pot riveted, welded design, and then we got fabricators to make this really nice, more durable trap. But there's lots of ways to do it. Fitzsimons decided he would do it quantitatively on the bottom by diver checking them. He figured that this was actually sampling that area, and you get a fry per unit area. Well, it's not, because the fry are moving all over the place within the substrate. It's not a good way to get quantitative. This is all catch per unit effort type of techniques. There's other ways of doing fry sampling. Again, can we get away from having to use divers if you don't have access to lots of qualified dry-suit divers? So we've got a little drop camera here. This is a camera with an electroshocker attached to it. You put that on the bottom with the electroshocker, and the fry respond. And you count them wriggling in a 10-second period, let's say, or something like that. So you get a quantitative estimate that way. And then you can get really high-tech, and you do the same thing, much, much bigger, and you add a suction something. Sure those were fried? Yep, they were fried. And you can take that down to, again, 50 meters or so and sample like on the mid-lake shoal in the machine. High-tech, lots of technological folks. And then we've got adult sampling. This is going backwards, right? What about early on? How many spawners are there? And there's various ways of doing that. A lot of those are ROV mediated, and I'll talk a little bit more about that. Many, many designs of doing that, but the nice thing is it gives you presence or absence. Are there spawners there? And when you see that, they're not there by accident. They're doing something there. You don't find more than one lake trout in a place unless they aggregate into spawn. Okay, so what life stage should you sample? You've got your eggs, you've got your fry, you've got your juvenile. I haven't mentioned the juveniles, the age 0s to say age 1. Do you want to sample recruits to know whether they're recruiting? Well, it depends, of course, what the question is. If you just want to know, for example, are they spawning on my reef? I go back to the idea that eggs are more abundant by an order of magnitude, or maybe 2, than the fry, just because of natural mortality. And they don't move around, though they do settle down into the substrate. So you strategize between what question you're trying to ask, what kind of skills, fabrication capacity, time, and weather you've got. If you're in Otsego Lake, you've got a pretty nice, I don't know that you get 5-foot waves often in Otsego Lake, whereas even in Lake Champlain, we can sometimes deal with a good 10-foot wave, and our stuff's getting really beat up, and so are we. So you've got to take all of this stuff into account. Where are they spawning? First thing you want to know, are lake trout using my reef, my site, what area? So you're going to look for adult aggregations. Jim Martin's told, I mean, what Jim and Jason are doing out there, I mean, yes, that's how you do it. You use acoustic telemetry, say, where are you going? They tell you where you're going, and then you follow them. So you can also, and you can use gill netting, you can also use the sonar. Yes, there's a lake trout on there. I don't care what the government folks think they are. There are lots of big echoes in one place. They become very identifiable. It's a lake trout, and then you put your cameras down, and you put your divers down, and you see that there's adults down there. So, are they spawning there? You want to sample eggs? Again, many ways. You've got divers, scuba, that is a natural occurrence. It's a particular, we're after a particular storm, but yeah, they're spawning there. A lot of them. Put your ROVs down, or you can put benthic sleds down, and you can pull them up with jets of water or various ways. Those only give you, again, presence absence, basically, a lot of little, very, very generalized. Egg nets, egg traps, things like that give you relative estimates, and then, as I mentioned before, these egg bags and funnels give you absolute estimates of density. Very handy. Is egg incubation, I hadn't mentioned this before, when are they incubating? What if you get eggs and they're fried? There's that intermediate stage where you can put down various kinds of incubators, basically putting eggs in the various cells here, closing up that sandwich, putting it in the substrate, and at the end of the winter pull it back out again and say, we started with 50, what have we got now? And that can be very effective at looking at water quality, siltation, stuff like that, and that's being used a fair amount. Do they hatch? Again, various ways of getting free embryos. I mentioned the little fry shocker, and then we've got these fry traps. So again, partly what I'm looking at here is surface deployed, don't need divers. That's great. They do need a lot of effort and a lot of fabrication. And then, lastly, let's not forget that you might want to know whether recruitment's occurring, trawling. There's lots of papers about how to trawl for a juvenile lake trout. You get your little age 1s in this case. You can actually get age 0s in the fall. A very effective way to say, yes, they're entering the population. Good. We're on our way to recruitment, on our way to sustain natural population. So you got your age 1, 2, 3, 4 live school. That was Lake Champlain 2018. What resources do you need? You need money. Right? You always need money. Money not just for the people, that's obviously the basic of the boat, to build the gear and build extras. You're going to lose stuff, it's going to get damaged, money for the people to fabricate and repair this stuff. It's really nice to have prior knowledge of your site, have an idea where you're going. Again, I go back to Jason and Jim, acoustic telemetry will tell you where to go, but unless you've got that, you need to know something about your substrate. Have you got a good substrate? Yeah, that's an artificial reef. But are you looking in the right place? And then in that case, it's bathymetry of a spawning site. Fabrication skills, I mentioned what I mean with fabrication skills. Sewing. How many of you here have a sewing machine? Yes, right. It's really important. That's a skill. I've been teaching my graduate students how to sew. It's like, oh, I could use this for making clothes. Yes, you can. Right? You're repairing your blue jeans, whatever, right? Handy thing to have, and then lots of metal fabrication type skills. If you're going to use ROVs, they're off the shelf now. There's many ones. They're very cheap. You can build your own little home ones, but you do need to get some practice using them, and you need to have sort of a pilot who's got some experience, especially with the suction samplers and the electroshocking samplers. And you need divers. And they need to be dry suit divers, and be, younger than I am, resilient to the cold, but they're absolutely invaluable because at the bottom of everything, at some point, you want to be down there looking at the substrate. Is it full of silt? Is there deep enough piles of cobble? Is the gear staying in place? And so forth. You need field crews, thank you, Hannah. You need lots of time and a lot of replication to be out there putting stuff down, bringing it up, putting stuff down, repairing the stuff, putting it back down, and so forth, to repeat as needed. Lots of design inventiveness. This was specialized gear by Tom Binder. They had lake trout spawning under boulders. How do you sample under a boulder? Well, you get your divers, you modify your fry trap to have an extension to it. Now you've got a new technique on the books. Or this was again built by the Rockport lab, you know, specifically for doing actually sampling gobies, but again, modifications. Keep thinking about different ways of designing gear. And I don't want to forget the fact that I haven't mentioned perigonines anywhere in here. I haven't mentioned egg mats, which we're beginning to find out is good for perigonines. These are mats that sample eggs as they fall into furnace filter. Larval sampling, however, is very different. Right? Eggs are roughly the same, but larval sampling is almost better. So, you know, larval sampling, right? You wouldn't use that for lake trout. That's Robin's paper. Maybe she'll give that talk next time. So that's what I've got. I think, you know, in the long run, what we want to say is, come on, fish, what are you doing? Where are you doing it? This is just, you know, you ask the fish. But I want to just thanks to all of the people, many of you are in this room who are inventing this gear, trying this gear, failing with the gear, reinventing the gear, and putting a lot of work into this kind of sampling. So thanks to you all.